We will continue the presentation of multiple choice practice paper 1 by taking a look at the third division, which is of course multiple choice practice paper 1 part C. The entire paper is divided into 4 parts, and of course we have 60 problems. We are therefore looking at the third division of 15 problems. Number 31. O is the center of the circle ABC, and angle OCB is equal to 30 degrees. What is the size of the angle AOC? We are looking at the angle AOC. That is the angle that we need to find the size of. But we may solve this problem in either of 2 ways. Both ways will be by first considering that OC is equal to OB, which is equal to the radius of the circle. So OC is equal to OB, and of course we can see that OB and OC are radii of the circle, and they are therefore equal. This will make the triangle OBC isosceles. So the triangle OBC will be an isosceles triangle, with of course these two being radii of the circle. We have an isosceles triangle. So there we have the 2 equal sides, of course, that are represented by radii of the circle. In an isosceles triangle, the 2 equal angles are opposite to the 2 equal sides. This causes the angle OBC to be equal to OCB, and of course it will also be 30 degrees. So the 2 equal sides are opposite to the 2 equal angles. Therefore, this angle will also be 30 degrees. Now, if 2 angles are subtended by the same arc, AC in this particular case, the one at the center is twice the one at the circumference. This causes AOC to be twice OBC. So we are saying this arc subtends 2 angles. One is AOC and the other one is ABC. And we know that the one at the center, which is AOC, must be twice the one at the circumference. The one at the circumference is ABC. Therefore, this angle is 2 times this one. And we have angle AOC is equal to 2 times 30, which is equal to 60 degrees. The correct answer is option B. In this particular approach, we will take the isosceles triangle in consideration again. So we will consider the isosceles triangle again. And there we have it. That is our isosceles triangle. We have initially highlighted the 2 equal sides as before. And of course, we know that from the previous take on this problem that OBC is also equal to 30 degrees. In the triangle, the 2 known angles are each equal to 30 degrees. The other one is what remains of 180 degrees. Of course, angles in a triangle add to give 180 degrees, and we know these 2 angles. We therefore can determine that third angle. And of course, it is equal to the rest of 180 degrees. So we take 2 times 30 from 180, and the result is 120 degrees. So these two are taken from 180, and that is what this angle right here is, 120 degrees. Now we have two angles on a straight line. One of them is equal to 120 degrees. The other one is what remains of 180 degrees. So we have this straight line here, and we have this angle and another one. The angles will add to give 180 degrees. Therefore, the unknown angle is what remains of 180 degrees if we take 120 degrees from that. So 180 degrees minus 120 degrees is equal to 60 degrees. There we have it, just as before, and the correct answer is option B. In the options, the correct answer is accompanied by distractors that are the result of solving the problem in all kinds of incorrect ways. So we have a lot of distractors here that are, of course, answers that we would have obtained if we work the problem or solve the problem in an incorrect manner. And of course, we are adding two fractions, 6p over 5q. We are adding that one to 4r over 3s. So we are adding these two fractions, and we are to determine the correct answer from the options that we have there. The most important thing to note is that we are adding fractions with different denominators, and we may recall the procedure for such from our primary school experience. So we have learned how to add fractions that have different denominators from our primary school experience. The only difference is that we are dealing with algebraic expressions rather than numbers only. So in this particular case, we are taking a look at algebraic fractions rather than numbers only. But the principle will be the same, and we will follow some of the same procedures. The principles to be applied will be the same as before. Namely, find the LCM of the denominator, that is, the minimum expression that each of them can divide into without leaving a remainder. So that is what we mean when we say find the LCM of the denominator. We need the minimum expression that 5q and 3s may divide into without leaving a remainder. And of course, that common denominator is 15qs. And what do we say? Just as we would have in the primary school level, we would say 5q into 15qs. When we get that answer, we multiply that by 6p. So we say 5q into 15qs is 3s. Then we say 3s multiplied by 6p, and we get 18ps. We then say 3s into 15qs, and that will give 5q. We take 5q and multiply it by 4r, and we get 20qr. And that is our answer. There we have our answer, option D. No problem with that. On the next slide, we will place some of the algebraic expressions under the microscope. With the assistance of a table, we will make use of repeated division in order to find the LCM of 5q and 3s, and that is in the same manner as we were taught in primary school. They will be the initial expressions in the table. So 5q and 3s will be the initial expressions in the table, and we are required to use repeated division. and we are going to proceed in the same manner as we would have if we were in primary school, using the same principles all over again. Find the smallest prime number that can divide into 5q or 3s. That is without leaving a remainder. So if it can go into 5q or 3s or both, then we may choose that prime number. It turns out to be 3. So 3 is the number that we are going to be using. We are using the smallest prime number that can go into any of those. And 3 is that smallest prime number. Now we will say 3 into 5q. 3 cannot divide into 5q. 5q will return unaffected in the next row. So when we say 3 into 5q, cannot be done without leaving a remainder. So 5q returns to the next row. Then we say 3 into 3s. And of course, the 3's will cancel and the s will remain. Then we go again and we say, what is the smallest prime number that can divide into that expression? Or we may say into 5q or s without leaving a remainder. So if it can divide into 5q, or it can be divided into s, or it can be divided into both of them, we will use it. Of course, the only one that we have that can be divided into this expression is 5. So we are using 5. Of course, 5 into 5q, the 5's will cancel and we will have the quotient of q. Then 5 into s, it is an impossibility, so the s will return unaffected. Like that. Now we have finished with the numbers. Let us move on to the letters, taking the first one in alphabetical order. So we are finished with the numbers. We will move on to the letters and we will take them in alphabetical order. Which one will go first? Q. Q comes first in the alphabet. So Q will be first. And we will say Q into Q, anything divided by itself is equal to 1. So Q into Q is 1. Q cannot go into S, so we will cause the S to return unaffected. Then finally, what is the letter that we will use to divide in this particular case? The only one that is left is S. So we will say S into 1. Of course, the 1 will return unaffected. Then we will say S into S. Anything divided by itself is equal to 1. Now that all is reduced to 1, that means we have the expression here reduced to 1 and the one on this side also reduced to 1. There is no way that we can go any further. So we will find the LCM. We will find the LCM of the expression by multiplying all of the factors. We have all of the factors there on the left hand side or in the leftmost column. So here we have them 3, 5, Q, S. So 3 multiplied by 5 multiplied by Q multiplied by S is equal to 15QS, and that is our LCM as we had on the previous slide. $60 minus y is less than 20. Then a possible value of y is, of course, we will begin the solution of this inequality by subtracting 60 from both sides. So 60 will be eliminated from the left hand side. On the right hand side, 20 minus 60 is equal to negative 40. So we will attempt to solve this by eliminating the 60 that we have here. Don't be blinded by the negative sign that we have here. The negative sign is pertaining to the y, not to 60. There's no sign accompanying 60. Therefore, we assume that it is a positive 60. In eliminating 60 from the left hand side, we will subtract. So 60 minus 60 is 0. We cannot leave it like that. We have to subtract 60 from the right hand side also. So we will subtract 60 from both sides. And what will happen? 60 minus 60 here will give 0, and we will have only a negative y on the left hand side. Then we will say 20 minus 60, and that is equal to negative 40. We may say that 60 is transposed to the right hand side, causing its sign to change to negative. So there we have it. The 60 is transposed to the right hand side, causing its sign to be negative. 20 minus 60 is negative 40. Or we may say that we eliminate 60 by subtracting 60 from both sides. Then 60 will be eliminated completely from the left hand side, and on the right hand side 20 minus 60 is a negative 40. Y is negative as we have it right here, which is the proposed subject. We may address this problem by multiplying or dividing through by a negative 1. Both will have the same effect. So if we multiply or divide by negative 1, that will cause the signs here to be changed. So there we have it. Y is greater than 40, whereas we have the less than sign here. Why is that so? Notice that all signs are changed, including the inequality sign. The inequality sign is changed when multiplying or dividing an inequality by a negative quantity. So if we are multiplying or dividing by a negative quantity, the rule is the inequality sign needs to be changed also. So there is your answer. Y is greater than 40. Which one is greater than 40? It cannot be equal to 40. We have strictly greater than 40. So it cannot be equal to 40. Y is greater than 40. It therefore cannot be equal to 40. The correct answer is therefore option D. Let us take another look at the problem on the next slide. Same problem. This time, let us attempt to get the subject to be positive. The proposed subject is this negative y that we have here. Or we will say the proposed subject is y. And it is negative. We therefore are attempting to get the subject to be positive. And that will be done by adding y to both sides. If we add y on this side, we will have a negative y plus y is equal to 0, and the y will be eliminated from this side, and then we will have 20 plus y on the right hand side. So we may say also that y is transposed to the right hand side, causing its sign to be changed to a positive sign. So there we have it. And then what? 20 will be subtracted from both sides, eliminating 20 from the right hand side. And 60 minus 20 is equal to 40. Now we have this y on the right hand side, and it is accompanied by a 20. We therefore need to eliminate 20 from this side, and that will be done by subtracting 20. But of course we are talking about an inequality, so we need to subtract 20 from both sides. 20 will be eliminated from the right hand side, and 60 minus 20 is 40. So we have 40 is less than y. So 40 is definitely less than that number that we are looking for. 40 is less than y. Which number in the option is 40 less than? Only 50. The answer is option D. So 40 is less than y. So we are looking for a number that 40 is actually less than. And of course, that number is 50. And option D is correct. We may reverse the inequality, causing y to appear on the left hand side. So we may reverse this. Y on this side, 40 on the other side. Like so. Notice that by so doing, the inequality sign will also change. So when we are reversing an inequality, the inequality sign is required to be changed also. This is another circumstance in which the inequality sign needs to change. This is by no means alarming, because if you are older than your sister, then your sister is younger than you. And the solution is just as it was in the first take. Right? So we had it initially, the first attempt at the problem gave y is greater than 40. And we have it right here again. Y is greater than 40. We have no doubt that y is equal to 50. Here we go again. In the attempt to save time, y and 20 may be transposed in the same step. That is what we usually do. If we have some transposition to make, we can do a few of them in one step without causing any harm or any alarm. Then we generally progress in that manner. The effect is y becomes positive on the right hand side, 20 becomes negative on the left hand side, and of course 60 minus 20 is equal to 40. So we cause the negative y to be that side, we have a positive y, and the 20 here we have negative 20. So negative y will be to positive y on the right hand side, and 20 on the right, negative 20 on the left. And of course 60 minus 20 is 40, and we have 40 is less than y, and the same question will appear again. 40 is less than y. Which number in the option is 40 less than? And of course only 50. The answer is option D. Again, the smallest of three consecutive prime integers is x. The sum of these three integers is 57. Which of the following equation best expresses this information? So the smallest of three consecutive positive integers is x. The sum of these three integers is 57. Which of the following equation best expresses this information? It is not necessary to state that the integers are positive. Well, we may have the statement that the integers are positive to make life easy for you, or to remove some amount of ambiguity and uncertainty from your mind. But it is not necessary to state that it is positive. As long as the numbers are consecutive, integers, the resulting expression will be the same. So as long as they are consecutive integers, the expression will be the same. The first integer is x. So first, x. Since they are consecutive integers are like 3, 4, 5, 6, 7. And if we want to take a look at them in a negative, we may say negative 5, negative 4, negative 3, negative 2, negative 1, increasing like that. Or if we want to take it in the region of 0, we may say negative 2, negative 1, 0, 1, 2, 3. Right? Just as you would have them on your number line. Since they are consecutive, the second is greater than the first by only 1. So to get the second, we just add 1 to the first. There we have it. Also, the third is greater than the second by 1 because they are consecutive integers. So we are going to add 1 to the second. And what is the second? X plus 1. So the third is x plus 1 plus 1. And of course, 1 plus 1 is, everybody knows that. So we may change that 1 to x plus 2. So this third integer may be written as x plus 2. Right there, no problem whatsoever. Now it says that the sum of these integers is 57. Now let us add the three integers. Let us add them. We have x going, then x plus 1, then x plus 2, and our addition signs. We are adding them. And do not forget that the result is equal to 57. What do we do then? Equal to 57. And we do our match up and we realize that the correct answer is option D. The vector AB maps the point P, 3, 2 onto its image P prime, negative 1, 5. Then AB is, that's a very good question. And it is based on some very beautiful topics in our mathematics. Transformation. Before solving the problem, let us take a look at the principle on which its solution is based. So we say that this vector maps this point onto this one. Now, in which transformation do we use a vector to map one point to the other? It is said that the matrix of a translation is a column vector that is added to each point that we are transforming. Therefore, we are sure that we are talking about a translation. And what is the principle? The matrix of a translation is a column vector that is added to the point that is being transformed. So that is the principle that we are going to use and solve this problem. May not appear as if it can be used to solve the problem, but let us take a look at it in a few seconds. First, identify the point that is being transformed. We have the point that is being transformed, 3, 2. There we have it. What do we know? The matrix of translation is a column vector that is added to that point. The matrix vector of transformation is required to be added to it. So we are going to add the column vector to that point. Right? There we have. The column vector is added. Or I would say column matrix, but it's a vector, is added to that point. And what? There we have the resulting point. The sum of the two will result in the image of the point. So let's have the image on the right hand side. So the initial point plus the vector is equal to the image. That's it. But we need to make the vector the subject of the formula in order that we can find what the vector is. So to find the vector, the original point is transposed to the other side. This is the original point and this is the image, of course. Or we might say the object and this is the image. So when we transpose, this will be subtracted from the right hand side, and we have negative 1 minus 3 is negative 4 and 5 minus 2 is 3. So the vector will be negative 4, 3. And of course we can see that we have that represented by option A. Number 36. O is the center of the circle. AC is equal to BC. Angle OB is equal to 140 degrees. And we need to find angle OBC. We need to find angle OBC. And of course we have some very good distractors, and we'll take a look at each one as we move merrily along. What do we know if we need to find the angle OBC? OBC. Right. So some students will find the first angle. Some of these angles are easily found. We know that the angle at the center is twice the angle at the circumference, which is 70. It's there. And we know that if we have 140 here, then this being the radius of the circle, this also being this radius of the circle, the angles that we have here will be equal. And of course we will take this 140 from 180 and divide the result in 2, and we will get, no doubt we will get 20, and the answer is also here. And almost anything that we can do that is illegitimate, any legitimate step that we can take, the answer is there for it, I think. So let us look at determining the one that they ask us for. Triangle AOB is isosceles, which is AOB is isosceles because OA and OB are radii of the circle and must be equal. No problem seeing that we have an isosceles triangle right there with those two sides being equal. In an isosceles triangle, the two equal angles are opposite to the two equal sides. So this is an equal side, so opposite to that we have one of the equal angles, and this is another side. Opposite to it we have one of the equal angles. One angle is 140 degrees. The rest of 180 degrees will be shared between the two angles. So we have 180 degrees and we are subtracting this one, and we get 40. So these two angles are equal, and to get the size of each one we will divide 40 equally into 2, and we will get 20 degrees for each one of them. Good. Is that what we were asked to find the size of this angle? Let's go again. Angle OBC. OBC. So we have found 20, and the answer is there. And I'm very happy because this problem is a neatly organized one. Now, if two angles are subtended by the same arc, AB in this case, so we have the arc AB, and we have two angles subtended by that arc. So this is the arc AB, and we have two angles that this arc subtends. One is this one that we have right here, which is 140 degrees. And the other one is the one that we have right here. So the two angles are subtended by the same arc. The one at the center is therefore twice the one at the circumference. The one at the center is twice the one at the circumference. Therefore, this one is 140 degrees. What is the size of the other one? The other one will be half the size of this one. So this one is 140 degrees. The one that we have here is half of it because the one at the center is twice the one at the circumference. So that one is equal to 70 degrees, and we have that answer right there also. So no problem seeing 140 divided by 2 is 70, which is the size of the angle that we have right there. And of course we have the one for it right here. But is that what is required? No, because the angle that is required is OBC, which is OBC. Now we are told that AC is equal to BC. This time we need to be told that. So if AC is equal to BC, it makes this triangle also isosceles. With AC is equal to BC, ABC is also an isosceles triangle. ACB is equal to 70 degrees as we have discussed before. The rest of 180 degrees will be shared between CAB and CBA. So we have, this is 70 degrees, and we have an isosceles triangle here. Right, so the two angles that we have here and here are equal. And of course, being a triangle, the angles will add to give 180 degrees. So to find the size of these two angles which are equal, we will take 70 from 180 degrees and divide the result by 2. So we get 180 minus 70 is 110. And we divide 110 by 2, and that is equal to 55. And the answers are there also. Very nice. But we do not need A, B, C. We need what? O, B, C. That's what we need. O, B, C. So we need this angle right here. This one right here. That is the one that we need. OBC is the difference between ABC and ABO. So the one that we need right here is the difference between ABO and ABC. Because we need this one right here, this little one. So we'll subtract 55 minus 20 is equal to 35 degrees. The correct answer is option B. Finally, we arrive at our correct answer. And as I said before, this problem is a neatly designed one with all of the angles that we determine along the way. This is a problem for students who have a lot of stamina, resolve, and, as I always say, presence of mind. So we need to exercise some presence of mind, calculating all those angles correctly and knowing that they are not the answer that is required. Then to finish up by getting the correct answer that is required. During a sale, a discount of 15% was given off the marked price of a chair. If the marked price was $115, then the sale price was $100. Well, it seems as if $100 is the correct one. 15%, 115 down to 100. To some, it would seem the obvious answer, but to me, the obvious answer is 97.75, which is $97.75. We'll take a look at why 100 is incorrect, why 97.75 or $97.75 is correct, and also how we may arrive at our answer with little or no calculation. Although it is not impossible, reducing 115 by 15% is a little awkward without a calculator. Surely that is what is required, with the problem asking for a discounted price when the marked price is given. So we are going to reduce 115 by 15%. That is what we are required to do. And I'm saying that it is a little bit awkward without a calculator. We are saying that the correct answer is $97.75. After reading the problem, it did not take me an additional 2 seconds to determine that option A is correct, and you should be able to do it too. So, read the problem, and if you know what you are doing, it shouldn't take you an additional 2 seconds to realize that the answer is $97.75. This is one problem that did not require that you work it out, but to just use your common sense and arrive at the answer. So when you have a multiple choice problem, usually if the digits are a little bit awkward, making the calculation without a calculator. Generally, we should be able to arrive at the correct answer without actually doing any manipulation of the digits. We just need to use our common sense. 15% of 100 is 15. If you can see this, then you are on your way. If not, you will have to go through a longer process. So we are saying that what? 15% of 100 is 15. Now what do we have? 115. 115 is greater than 100. So since 115 is greater than 100, 15% of 115 must be greater than 15. So we have there 15% of 100 is 15. So 15% of 115 must be greater than 15. Right. Therefore, by discounting, we will be reducing 115 by a number that is greater than 15. So if we are subtracting a number that is greater than 15 from 115, then the answer will be less than 100. If we take 15 from 115, we will get 100. But we are not taking 15. We are taking a number that is greater than 15 from 115. So the result is going to be less than 100. And how do we know that we are subtracting a number that is greater than 15 from 115? Because 15% of 115 is greater than 15% of 100. 15% of 100 is 15. Therefore, 15% of 115 must be greater than 15. So, from 115, you are subtracting a number that is greater than 15. The result must therefore be less than 100. And the only one that we have right there, the only number in the options that is less than 100 is 97.75, and this belongs to option A. So you just look and you know 115 greater than 100. 15% of 115 must be greater than 100. We are subtracting a number that is greater than 15 from 115. The result must be less than 100. And then we know that the answer is $97.75. And that is our correct answer. A and B are two sets, and A is a subset of B. If NA is equal to 6 and NB is equal to 15, then what is the number of elements in A union B? So we have NA is 6 and NB is 15. Then what is NA union B? And of course, we can just reason that out. Although we can see there that there's a little bit of hidden, not necessarily secret, but jumping to conclusions is bad exercise. And we see the 6, we see the 15. 6 plus 15 is 21, and we are caught in a net. So we need to do a little analysis. We may put forward a simple argument that will cause us to end up with the answer in a short period of time. So put our argument together. A is a subset of B. That means A is inside of B. A is inside of B. Therefore, all of the elements that are in A, every single one of them, also in B. So all of the elements in A are in B. This causes the 15 elements of B to be inclusive of the elements that are in A. So all of the elements that are in A are also in B. The union of the two sets will contain 15 elements. Why? Because 15 elements are in B. And we are sure that those 15 elements are also inclusive of the elements, which of course we have 6 elements that are in A. So the 6 elements of A are included in the 15. Why? Because A is inside of B. The elements of A will not increase the total because those elements are also inside the set B. So we are sure that the answer is C. The correct answer is option C. Good. A has 6 elements. B has 15 elements. All of those elements that are in A are in B. Therefore, the total number we have is still 15 because the 6 that we have in A is not in addition to the 15 that we have in B, but they are also included in the 15 elements that are in B. So we are sure that in all we only have 15 elements. Let us take a second look. So we will use in this particular case a Venn diagram in assisting us to solve the problem. There are 6 boys on both teams. Generally, when we are solving a problem in set theory, we generally put the information in the intersection of the two sets first. No problem with that one. There are 6 boys on both teams. So the 6 that are on both teams are shared members and will be in the intersection. Right there. Then 4 who are on neither team. So the 4 will go in the Venn diagram, but not in any of the sets. There are 11 boys in each team. For each team, we have 6 members already accounted for. The number unique to each team is the rest of the 11s. So we have 11 on either team, but we have 6 right here, shared between 2 teams. Therefore, we will have the rest of 11 in C only and F only. So 11 minus 6 is equal to 5, and we'll have 5 there and there. So how many boys are there in form 3B? All we have to do is add those numbers. The number of boys in the form is the sum of all the numbers in the Venn diagram. So let us add them. 5, 6, 5 again, and then 4, separated by addition signs, and the result is 20. So we have 20 boys in form 3B. The correct option is B. The coordinates of the point A are, so we need to find the coordinates of this point, which is A. And what do? The coordinates of the point is the combination of X and Y movements that may be used in locating the point. As usual, X goes before Y. So X will be first, Y is second. Let us put up our little template right there that we usually have. We usually have the coordinates in brackets separated by a comma with the X going before the Y. So what will be the X movement and the Y movement in locating the point A? We are using color codes. The X is in red and the Y will be in blue. So there's your X movement from here to here, only 1 unit. So we have a movement by 1 unit in the positive X direction. So 1 goes there. And then finally, we have another movement in the Y direction. And see, we can see from here, 1, 2, 3 units. So it is followed by a movement of 3 units in the positive Y direction. So we will have a positive 3 there, with or without the sign. No problem, seeing that the coordinate is 1 for the X, 3 for the Y, and that is represented by option D. the gradient of AB is, so we are determining the gradient of AB. The gradient of AB may be quickly calculated dividing the vertical height of AB by the horizontal dimension. So we have our fraction bar, and we are going to put the y movement from A to B here and the x portion of the movement from A to B in the denominator. So there we have them, y as usual in blue and x as usual in red. So we take a look at the y first. Being the numerator, we take a look at it first. What is the y movement? Because we are going from A to B, and we can see that to get there, the y movement will be from here to there, and that will be how many units? The vertical shift is by 3 units, so 3 will go right there. What about the x movement? As we can see, 1, 2. So we go down by 3 and we go across by 2. So the horizontal shift is by 2 units, going from A to B, left to right. So we have 2. So we have 3 over 2. But is that correct? Do we have that answer there? Yes, right there. But that does not mean that that represents the correct answer. Is there anything else to it? Let's see. Do not forget that a line that slopes in the direction of the uplifted left hand has a negative gradient. So there we have the uplifted left hand, or the entire arm. So we will say then the left arm is lifted when we have it sloping in the direction in which the left arm slopes like that. We are talking about a negative gradient. Therefore, we are sure that the gradient that we have right there is negative. Right? So that we have it sloping in the direction, same direction as we would have if we lift our left arm up like that. So the gradient is definitely negative. Right? So we know now that our answer is negative 3 over 2, and that is represented by option A. Again, the natural movement in the coordinate system is from left to right, and the gradient of the line AB may be found by considering this fact. So, correct movement, or the natural movement in the coordinate system, is from left to right. Therefore, if we are going from A to B, or along that line AB, we will go from left to right along that line. Therefore, we will start at left and end at right. That is a normal and a natural movement in the coordinate system. So what do we know? If we are going from left to right along the line AB, the movement of the y will be in a downward direction, as we can see right there. Any movement down is a negative y movement. The movement of the y is therefore negative 3. So remember, the natural movement is from left to right. So which one of these points is left of which one? Of course, A is somewhat to the left of B. So we are going to start from left and we end up at right. If we are moving in that direction, notice that we will be going in this direction, and we will be going down in the y direction, which is the negative y direction, which of course is negative 3. While going from A to B, which is of course from left to right, the x movement is to the right, which still constitute a positive x movement by 2 units. So we are still going in this direction from left to right and of course by 2 units the x value or the x movement is positive, so positive 2. So no harm seeing that the result is negative 3 over 2, which of course is option A and the same that we have calculated on the previous slide. The correct answer is option A as before. We may find the gradient again. The gradient could have been found by making use of the coordinates of A and B in a formula. We have just found the coordinates of A, which is of course 1, 3, and the coordinates of B are 3, 0. Take the formula for the gradient. So we are going to use a formula or the formula for finding the gradient. And of course it's y2 minus y1 over x2 minus x1. That one is well known to all CSEC students. We may use any one of these points to be x1, x2 or y1, y2. We only need to be consistent. We only need to be consistent when we are subtracting or finding the x difference and the y difference. So we have y2 minus y1 over x2 minus x1. We may therefore say 0 minus 3 over 3 minus 1. Or we may say 3 minus 0 over 1 minus 3. So 3 minus 0 over 1 minus 3, or we may say 0 minus 3 over 3 minus 1, as long as we are consistent with where we begin and where we end. So insert the numbers in their respective positions. So what do we know? We have 0 minus 3, that means we are beginning here. So we say 0 minus 3. We also need to begin here and say 3 minus 1. And 0 minus 3 is negative 3, and 3 minus 1 is 2. So there we have it. M is equal to negative 3 over 2, just as in the two other cases, the two previous cases that we have examined. And finally, we need to determine the equation of the line CB. Determine the equation of the line CB. Where is CB? Here we have it. So the line segment CB is a portion of the x-axis. So there we have CB, a portion of the x-axis. Therefore, if we know the equation of the x-axis, we are done. It will therefore have the same equation as the x-axis. As we say that, some people say, yeah, x is equal to 0. And they are wrong. So there we have the x-axis, or the portion of it that we have in that diagram. We have highlighted that portion of it. The equation of the x-axis is y is equal to 0. The y ordinate of every point on the x-axis is equal to 0. So everywhere on this axis, the y ordinate is equal to 0. So the equation of that line is y is equal to 0. So y is equal to 0 is our correct answer. The correct answer is option A. There we have it. The pie chart, not drawn to scale, represents the masses of ingredients in a cake. The total mass is 288 grams. What is the combined mass in grams of fat and sugar? What is the combined mass of fat and sugar? we know the total mass of the cake. We first need to know the fraction of the entire cake that is represented by fat and sugar. Where is fat and sugar? Right here. Good. The angle associated with fat and sugar is equal to what remains of the 360 degrees when the others are subtracted, since they are the only ones that are not accounted for. So we have right here fat, sugar, and we have the entire remainder of the cake, and we have here all of the associated angles are included. They are known, they are given. But we do not know the angle associated with the combined mass of fat and sugar. Right, they are accounted for. So we know that the angle will be what remains of the 360 degrees when these are subtracted. Of course, the angle of one revolution is 360 degrees. So we add, and when we add, what do we know? 195 degrees, we have 20 plus 75 plus 100 right there, and the answer is 195 degrees. There we have our answer. There is your appropriate distractor. But let us continue. It is not the correct answer, it's just a distractor. Of course, after determining the angle, we do not imagine that we are actually finding the combined mass in grams of fat and sugar. There we have it, not mass. The mass is given in grams right here. So the mass is in grams right there, and we have the angle. We have not, by any means, found the associated mass. And as a matter of fact, what we have found here is not the combined mass of fat and sugar, but the combined mass of those that are given already. Now we need to find the associated angle, and we will find the associated angle by subtracting this that we have right here from 360 degrees. So we subtract 195 from 360, and the result is 165 degrees. And of course we have our answer right there. But it is another distractor because we need to find the mass. So now we have the angle associated with fat and sugar. We need to find the mass, the combined mass in grams of fat and sugar. So we have the angle associated with it. So there is your other distractor. But we are not done yet. 165 degrees is the angle associated with fat and sugar. Divide that by the angle of one revolution, which is 360 degrees, for the fraction of the pi that they represent. So we need to know the fraction of the entire pi that is represented by fat and sugar, and that may be determined by dividing by the angle associated with the entire pi. So what we have done here, we have found the angle associated with the known elements of the ingredients. Right. So we have the known ingredients right here. 20 degrees, 75 degrees, and 100. Those are the ones that are known. We have found the combined angle. In order to find the angle associated with fat and sugar, we have subtracted that from 360 degrees. Then we have 165 degrees. But that 165 degrees is not representing the combined mass of fat and sugar. It is just representing the angle associated with them. Now, in order to determine the mass, we will have to find what fraction of the entire cake is represented by what we have here, which is the combined angle associated with fat and sugar. What fraction of the cake that represents. And we will divide by the angle associated with one revolution, or the angle of the entire pi. We will divide that by 360 degrees. Right there. After finding the fraction, what will we do? We multiply the fraction by the mass of the entire cake for the combined mass of fat and sugar. Therefore, fat and sugar is represented by a fraction of the entire cake. As we can see, we can determine that fraction by dividing the angle by the total. So the angle associated is 165, and we are dividing by 360. That is a fraction. It is a fraction of the entire cake. So that fraction needs to be multiplied by the mass of the entire cake in order that we may find the total mass of fat and sugar. So we multiply by 288. We will now reduce the expression that we have, that one, so that we can get our answer. The fraction may be reduced by a common factor of 12. Of course, 12 into 360 is 30, and 12 into 288, I think, is 24. So, there we have 30, and there we have 24. I was right. Then we need to reduce the entire thing further. Of course, we can reduce it further. Now we will choose a common factor of 6 to reduce the expression by. So 6 into 30 is 5, and 6 into 24 is 4. And of course, we see a common factor 5 here. And we are saying that 5 may go into 165 exactly 33 times. So 5 into 16 is 3 times and carry 1. 5 into 15 is 3 again, so we have 33. So 5 may go into 165 exactly 33 times. Alright, so what do? We say the 4 multiplied by the 33 that would get here, and that is equal to 132. And that turns out to be our correct answer. The correct answer is option B. The product of 4 times R and 3 times S is? Product is the result of multiplication. So let us multiply. But what do we multiply? 4 times R is 4R. And we need to multiply that by 3 times S, which is 3S. At this level, the distractors in this problem should mean nothing to us. Simply multiplying the measly algebraic expressions give 12RS. So that's all there is to it. 4 times 3, 12, R times S, RS. No problem. The correct answer is option B, 12RS. There's nothing to it. The area of the circle not drawn to scale is 27 centimeters squared. What is the area of the shaded sector? We know the total area. So we have the area of the entire thing. The shaded sector is a fraction of the circle. So all we need to do is find the fraction that is represented by the shaded region, and that we will do by dividing its associated angle by 360 degrees. So the entire revolution is 360 degrees. We have 150 degrees right here. So what fraction does that represent? Of course, 150 divided by 360. There we have it. And of course, that is the fraction of the entire area. And the entire area is 27 centimeters squared. So we multiply that fraction by the area of the entire circle in order to give the area of the shaded sector. that is multiplied by 27, of course. And what do? We reduce the fractions by a common factor of 30. 30 into 360 will give 12. 30 into 150 will give 5. We can further reduce the expression by a common factor of 3. So 3 into 12 is 4 and 3 into 27 is 9. So we have there 5 9s, 45 to be divided by 4. So 9 multiplied by 5 is equal to 45, and 45 divided by 4 is 11 1/4. As we can see, we know that 45 is very close to 44. 44 divided by 4 is 11. So no doubt the one that contains 11 would have been the correct answer. But of course, we know that it is 11 times and the remainder is 1. So the remainder 1 is placed over 4 and we have 1/4. So it is 11 1/4 centimeters squared. 1/4 is equal to 0.25, or common fractions represented, of course, as a decimal fraction. The correct answer is therefore 11.25 centimeters squared, and this is represented by option A.